Greetings everyone. Today we are going to explore the quadratic formula. Now these examples are Algebra 1 level, so make sure you're on the right video. And if you are in my class, you likely have a note sheet to fill in. If you don't have it with you, these can easily be written on your own paper. All right, let's quickly review. We have solved problems like this year so far. We have isolated, meaning move everything to one side. And then our goal has been to factor because we have a quadratic trinomial. But when I try to factor, no combination of these numbers will get me to 4. And so I come to an example that's not factorable, but all equations are solvable. And so today we're going to learn about how am I going to solve this equation. We're going to solve that equation by the quadratic formula. And this is the quadratic formula. This is something you're going to want to start to memorize over time. You're going to use it in every math class from here on out. Hope you enjoyed that little tune, but any little tricks to help you memorize? There's so many options. That's just one of the little songs that might help. If you weren't able to hear it for any reason, I've got that YouTube link there so you can check it out for yourself. Let's talk about the steps for using the quadratic formula. So step 1, we have to, as always, write our equation in standard form. So that's not new, that's old. Next, we want to identify our A, B, C. We've already identified, so we're just plugging them in. That's the new piece. Step 3, we're going to talk about finding the discriminant. Now, to solve, you don't have to find the discriminant, but pay attention to directions in case I'm asking for that. As always, you want to simplify your formula, right? If I can reduce a fraction, if I can reduce a radical, I want to do so. And then step 5 is to state your solutions. Remember, we're looking for x equals. And in the past, we've had answers like integers, we've had answers like fractions, and we've had answers like reduced radicals. And so our answers are going to continue to look like this. The one difference is we might combine this idea. We might end up with an answer that looks like 2 plus or minus 2 squared root of 7. All right, our answers might just get messier. Okay, those are all the options though. All right, let's take a look at example 1. First, we have our equation. Let's identify the ABC because we're already in standard form. A is always your x squared value. B is always your x value coefficient. And C is always your constant, so nothing new there. We want to find our discriminant first. All right, you might need to write this down. Our discriminant is what's under the radical symbol. Okay, so when I go to plug in for my discriminant, I need to plug in my b value, b squared minus 4 times a times c. All right, we're replacing the radicand with the numbers that represent the letters. Now from here, it's just calculating, right? 4 squared, we always do exponents first. We take care of multiplying next, and then we subtract last. Now, if the discriminant, you might have to take these notes, if the discriminant is greater than 0, which this is, that means I'm going to have 2 solutions, 2 real solutions. Let's add a little piece of notes. You might have to pause this. If the discriminant is less than 0, it has 0 real solutions. And if the discriminant is 0, you're going to have 1 real solution. All right, so let's see what happens. I should get two answers out of this. So on the right side, we're going to use the quadratic formula, the whole thing, right? The whole thing. So let's plug in our A, B, C values. The quadratic formula is opposite b, or negative b, plus or minus the square root of b squared minus 4ac all over 2a. I'm trying to color coordinate for this first one, just so you can reference that. Now, let's take care of reducing. I've got a negative 4, and I got a 4 in the denominator. I feel like that part's just the easiest, right? It's always going to be a basic calculation. Now, the radicand is the discriminant. You guys, we already did this. We already did this work over here, right? We did b squared minus 4ac, and what we got was an 8. Now, I'm okay if you jump straight to the 8 as well, because you could use your calculator, right? Now, if you try to plug it all in, you can't take the square root of 8. So let's reduce. Here's how I want you to reduce. We have a plus minus, right? I want you to put the denominator separately under both pieces. I want you to split it up. I also want you to reduce radicals. So square root of 8 reduces to 4, 2. So this part is actually 2 square root of 2 over 4. Do you see how I did that? That means my final answer, negative 4 divides by 4 to get negative 1, plus or minus. We're dividing. We just spent all that time dividing radicals. That's going to be 1 square root of 2 over 2. I arrived at two answers. Two answers because I got negative 1 plus square root of 2 over 2 and negative 1 minus square root of 2 over 2. Now, let's talk about for a moment, you don't have to write this down, let's talk about what that looks like as a graph, okay? Square root of 2 is a crazy number, right? If I was to plug it in, it'd be decimals. And what this means is, when you do that, when you have x equals 2 decimals, right? I mean, those really are 2 decimal values. Look at my graph. If I graph this function, and you don't have to know how to do that yet, but look at my x values. Look at where it crosses the x-axis. It crosses at 2 weird decimals. And guess what decimals they are? They're the decimals we just found, right? Those dots represent the 2 answers we just found. All right, let's take a look at example 2. I'm going to go a little bit faster, so if you need to pause, please do so. Everything's in standard form. Check. Identify your A, B, C. A is 3, B is negative 5, watch your signs, C is negative 12. Let's find our discriminant. Discriminant is the radicand. Make that note if you need to. So I'm going to care about b squared minus 4 times a times c. Let's try that again. B squared minus 4 times a times c. All right, let's solve exponents first. Careful here. I'm multiplying. 4 times 3 times negative 12 is negative 144. A double negative here becomes a positive, so if I add those numbers, I have 169 for my discriminant. Now I want you to pay attention to these double negatives. It was subtracting and I had a single negative. That can often get mixed up, so make sure you're okay with that. Now, I have a positive number, which means I have 2 possible real solutions because it's greater than 0. All right, let's do the full quadratic formula. Quadratic formula is opposite b plus or minus the square root of b squared minus 4ac all over 2a. So opposite b, look what I'm doing with my color. Opposite of the negative, okay? And then my discriminant, we already did that work. That was 169. And then 2 times a. All right, let's simplify this. Opposite b, that literally means instead of a -5, I want a +5. All right. 169 is a perfect square. You guys got to have those memorized, remember? And 2 times 3 is 6. Now, this is a perfect answer, and I want a perfect answer. I want you to tell me what 5 plus 13 divided by 6 is, and I want you to tell me what 5 minus 13 divided by 6 is. Okay, so 5 plus 13, that's 18, divided by 6, that's 3. 5 minus 13 is -8/6, which reduces down to -4/3. There are my 2 nice answers. Now, those were 2 nice answers, right? So if I was to graph this, take a look at this graph, and I look at my scale, right? This is a perfect 3, and this is a -4/3. Okay, so that's great. We can see that we cross the x-axis at 2 true values. All right, example 3. My equation for this one, a little more basic. Remember that if you don't see a coefficient, it means your value is 1. Careful with your signs. I'm going to say my b value is -6 and my c value is 9. I'm going to use all one color, okay? So my discriminant is under the radicand. -6 squared minus 4 times 1 times 9. b squared minus 4ac. Okay, I get positive 36 because a negative times a negative is a positive. 4 times 9 gets me 36. Our discriminant is 0. That was a rule we wrote down on the front page, or example 1. If the discriminant is 0, that means there is one real solution. Let's see what that means, okay? Let's jump to the quad formula. Quad formula is opposite b plus or minus the square root of the radicand, we already did the work, all over 2 times a. What's the square root of 0? What's plus or minus 0? That all goes away, right? We've got 6 over 2. I mean, you could put a little plus 0 and a little minus 0 there, but that's not going to help. Our answer is just 3. Now, when we did factoring, we did this, remember, where we just said, oh, comma 3. We could write it twice. I mean, you could say that, right? You don't have to. And let's take a look at the graph for y. When I look at the graph, I see this perfect 3, and notice how we don't cross the x. We just sort of bounce off of the x at 3. See how that works? So it makes sense to have 3 technically twice. All right, last example that's likely on your notes here. I'm going to do all one color. A, B, C. Discriminant, b squared minus 4ac. Exponents first, then multiply, then subtract. Negative? A negative just, so I have 0 real solutions. 0 real solutions. Why is that? Well, let's do the quad formula and find out, okay? The quadratic formula's opposite b plus or minus the square root of b squared minus 4ac all over 2a. We could break apart that 84. We could do perfect squares, right? But have we ever, or can we, take the square root of a negative number? We can't, you guys. Our calculator won't let us do that. And the reason why, you'll learn about this in Algebra 2, the square root of a negative number is imaginary. This is an I, a fancy cursive I. We're not going to learn about imaginaries. This is the Algebra 1 video, but you could see my Algebra 2 videos if you wanted. And so, I mean, I could simplify as far as I can. So let's try it, right? Let's break down this 84, okay? So 84 and I'm going to guess 4, yeah? All right, so 4 and 21. So that'd be negative 6 plus or minus the square root, 2 square root of negative 21 all over 2. So if I split that up over 2, that means that cancels. So I've got negative 3 plus or minus the square root of negative 21. I mean, I could do that, right? But I have no real answers. So I'm okay if you just leave that. All right? But let's talk about the why. I have no real solutions. Let's take a look at the graph. Look at my x-axis right here. My graph never crosses, never bounces, that has nothing to do with the x-axis. That is why I have 0 real solutions. Now, this one might not be in your notes, but what I wanted to do is do a full example of sort of what you're going to see on some of your homework or on a learning check maybe, okay? I just want to do a full out, no steps or graphic support, all right? Step 1, write in standard form. I need to minus that 14x to the other side of the equation. Now I'm not going to slow down on that part because that is old news from our previous unit. There's no GCF, I can't factor, and so my A value is 1, my B value is negative 14, and my C value is 23. I'm going to straight jump into the quadratic formula. Quadratic formula is opposite B, plus or minus the square root of B squared minus 4AC, all over 2A. Oops, I just about wrote A. I meant to do a 2. All right, so looking at that whole setup, I'm going to take care of that radicand first. That radicand is messy, right? So I'm just going to work to the right here. 14 plus or minus all over 4. Let's take care of the easy stuff, right? 14 squared is 196. 4 times 2 times 23. Multiply those 3 numbers, and we get 184. Oh, hey, this subtracts nice. If I subtract those numbers, I get 12. See how I'm just bringing everything down? 12 breaks apart into 4, 3. So I have 14 plus or minus 2 square root of 3 all over 4. And I want you to separate those. 14 over 4 and 2 square root of 3 over 4. And let's see. Let's look at how this goes. Okay, so I can reduce 7 over 2 plus or minus square root of 3 over 2. Because that would be 1/2 out front, right? Oof, that was messy. Let me fix that. That's my answer. That's my x equals. Messy, but it worked out pretty nice otherwise. In the end, that just means I crossed the x-axis at 2 sort of crazy decimal values. Graphically, here's those 2 crazy decimal values, right? And feel free to use desmos.com/calculator to type that in and see what it looks like. Awesome. So again, if you need to, I know you were writing a lot. If you need to just rewind and just listen to some of the instruction, please do so. One of my suggestions as well, if you have questions, seek out other videos. Okay? There are so many videos about quad formula. So many, okay? Quad formula is a huge math topic. You're going to use it every year. So take a look. As always, make sure to check out Google Classroom to see what our goal is for today. Let me know if you have any questions, and until next time, have a good one.